Well, when it comes right down to it, if we're going to be able to find the trigonometric function of any angle in the plane, generally speaking in the textbooks, and when we run into it a lot of times, we reference these major angles. We're referencing our angles 0, pi over 6, pi over 4, pi over 3, and pi over 2, which we know to be 0 degrees, 30 degrees, 45 degrees, 60 degrees, and of course 90 degrees. And we use these special angles to help us ferret out the values of the rest of our trigonometric functions throughout the plane. So how do we do that? Well, here's where we know how to do it without a calculator, and you have to get good at this yourself. So how do I remember sine, sine, and cosine first? Because sine and cosine I can use to get the rest of these, and I'll show you how. All right, so if I want to get the values of sine and cosine, I'm going to do this here in just sort of a light color so that you see how this works. Let me just pick a nice light color pen. Let me do this in gray. Okay, I'll make it a little bit darker gray. We'll go with that one. Okay. So what am I going to get? Well, for sine, here's how I count it. 0, 1, 2, 3, 4. For cosine, 4, 3, 2, 1, 0. Here's the trick. Take the square root of each of these numbers and divide by 2. Take the square root of each of these numbers and divide by 2. And we do that for all of these guys right here. Now, of course, I'm not going to leave them in this form because, well, most of them anyways, because, well, when we can take a square root of 1, we make it 1. We don't make it square root of 1, leave that. But, okay, so what are our values here for 0 degrees? 0. Square root of 1 over 2, that's 1/2. Square root of 2 over 2 is itself. Square root of 3 over 2 is itself. Square root of 4 over 2 is equal to 1 because the square root of 4 is 2. So we reverse the situation. 1 square root of 3 over 2 here. Square root of 2 over 2 here. 1/2 here. And 0 here. All right, so how do we use that? Well, remember, sine over cosine of theta is equal to tangent of theta. So finding our values for tangent of theta is actually pretty straightforward as well. Take 0 divided by 1, we get tangent of 0. Take 1/2 divided by square root of 3 over 2, we get 1 over the square root of 3. Or if we rationalize the denominator, we write that as square root of 3 over 3. Take square root of 2 over 2 divided by square root of 2 over 2. Tangent of 45 degrees, or pi over 4, is 1. 60 degrees, radical 3 over 2 over 1/2 is square root of 3 over 1, which is just square root of 3. Take 1 over 0, well, that's undefined. So the tangent of 90 degrees would be undefined. Cosecant? Cosecant is the reciprocal of sine. So take all these numbers in our top row and let's take their reciprocals. Well, of course, that means that the cosecant of 0 would be undefined. The cosecant of pi over 6 is going to be 2 over 1. The sine of pi over 4 is going to be 1 over square root of 2 over 2. Now, if you write that, square root 2 over square root of 2, then rationalize and reduce it, that's just equal to square root of 2. So we don't even bother with this. Pi over 3, well, it's the reciprocal. So of the sine of pi over 3. So we would take 2 over radical 3 and then rationalize the denominator to make that 2 radical 3 over 3. And then finally the reciprocal of 1 is just 1. Secant, we're going to do the same thing, but it will look just like this line, only in reverse. It'll be 1. It'll be 2 radical 3 over 3. It'll be square root of 2, and it'll be 2, and then undefined here. So you'll notice that's what's happening, so we're just basically reversing these lines. How about tangent? Well, tangent and cotangent are reciprocals of one another, so we're going to reverse those lines too. That is, it will be undefined at 0. It will be square root of 3 at pi over 6. It will be 1 at pi over 4. It'll be square root of 3 over 3 at pi over 3. And it'll be 0 at pi over 2. Well, if we know these values, this is how we're going to use our information to get the rest of what we need to know.